So in our final question, we've been given this complex equation, and again, we need to leave our solutions in exponential form. So do you want to give this question a go yourself? You can pause the video and come back when you're ready. So welcome back if you had a go. We've got a real part of 16 and an imaginary part of negative 16 root 3. So our complex number will be about here. And this will be theta. So theta will be the arctan of the opposite divided by the adjacent. And this works out as negative pi over 3. And the radius will be the square root of the 16 squared plus 16 root 3 all squared. And this gives us 32. To an exponential form, z to the 5 will be the radius of 32 multiplied by e, and then negative pi over 3 plus the 2k pi. Then we'll take the fifth root of both sides. So z will be, using De Moivre's theorem, 2e to the negative pi over 3 divided by 5, so over 15, plus 2k pi over 5. And then I'm just going to simplify this addition here as negative pi over 15 plus 6k pi over the same denominator. So then I can simplify this. Z will be 2e to the 6k pi minus pi over 15i. And when k equals 0, we'll have our first solution. This 6k pi term will go. So we'll get 2e to a negative pi over 15i. When k equals 1, our second solution, we'll get the 6 pi minus pi. So this will be 5 pi over 15i. When k equals 2, then 3, we'll get 12 pi minus pi. So 11 pi over 15i. And then when k equals 3, this will become 18 minus the 1 makes 17, and that's outside our limits. So if we let k equal negative 1, then our fourth solution will be 2e negative 6 pi minus pi will give us negative 7 pi over 15i. And then when k equals negative 2, that 5 will be negative 12 pi minus another 1, so minus 13 pi over 15i. So these are our 5 solutions. Okay?